So now we continue our previous video, which was about integration by substitution, and now we have another case. So let us say we have the integral of maybe f prime of x, for example. We start with this, and then here we have, let us say, sine f of x, so dx, or maybe that can also be cosine f of x dx, or maybe it could be, here is also f prime, or it could be f prime e to the power f of x, so dx, and that could also be ln the natural logarithm of f of x, so dx. Here everything is by substitution. If we have everything as it, so that will be by substitution. Let us try maybe one example, or maybe it will be different from those cases. So this is just a few of them. So let us say example. Let us say we would like to find the integral of 2x e to the power x squared dx. So here obviously we have this function f of x, and we have its derivative here down. So then that means we choose u to be our function. So here in this case we say u is equal to this, and then here du dx. Let us do it step by step. So if we assume u to be x squared, so then that will lead to du will be equal to 2x dx. So in here you see dx, 2x dx is now du, and then x squared will be replaced by u. So then that means if we call this integral I, so that means our integral, we can rewrite it as, so now we change it, the integration by substitution, then we must need to change the variable here. So from x, then we will use u in this case. So now here we said we would have e to the power, now x squared is u, then times, so everything here which is 2x dx will be du. So now we know this integral is now easy, so it's just e to the power u plus a constant. But now we need to be careful, so we need to put u, so u was x squared, then that means we have to write the final answer in terms of x as a function of x, because the integral was respect to x. So this is one example. Let us take another example. Now those are simple examples, but now let us say that we have this, for example. So we have, so we have integral, now this time we take this maybe to the power 5, for example, and then we could have here inside 1 minus e to the power negative. In this case, let us say take 3 to the power, so 3x to the power 6, and then with respect to dx. So now it is not in standard form here we described above, and then in this case we can do the following. But the most important thing, as I said in the previous videos, we don't really care about the numbers and the sign, whether it is positive or negative. So those coefficients, we don't really care about them in this case. So but then we only care, you see here you have x to the power 6, and when you take the derivative, then this will be reduced, the exponent, so it will become x to the power 5. So then that means here we already have a function and we have its derivative, so independent of which coefficients do we have here in this case. So then that means, let us say, okay, so now let us say this is everything here is my u, or even you can just say u is equal to x to the power 6, and then we will see what we get. So then let us do it. So here we have u is equal to maybe I can put everything here, that is also okay. So negative 3 x to the power 6. So then that means du, we just need to differentiate. So we multiply this by this, then we get negative, so 18 x to the power 5 dx. So but now you see that here we have 3, and then so here we have 3, and then here so we have 3x to the power 5 dx. But then here we got this. I mean, what we need to do, just to be safe, if we would like to replace this correctly, then what we would do, I mean, we can multiply by 3 in this case, negative 3 by 18, and here also by so we multiply by negative 3 divided by 18, because I mean the 18 would cancel out, and also the negative sign here, so it is positive. So that means we would have negative 3 divided by 18 du. So in this case it will be 3. So here we have 3, and then we multiply by x to the power 5 dx. So now you see here, everything here times this one will be equal to negative 3 divided by 18 du. So now let us replace our variable. So as we said, so we can still do it here. So now let us call this integral I. I mean, let us say this is I. So instead of rewriting all the time, you can just give it so a name. I mean, I is a function of x, of course. So but then let's do it here. So our integral I will be can be written as follows. So now we have seen that 3x to the power 5 times dx is already du divided. I mean, that was here negative 3. We can put it here. So we have negative 3 divided by 18 du. That is for this part, which is 3 x to the power 5 times dx. But then we be careful. Here we have 1 minus. I mean, that would also be here. I mean, the 1 we did not do anything for this, minus e, and then we replace this by u. So then that will be to the power u. So you see that now we wrote everything in terms of u. That means we have changed our variable here. So I mean, since this is a constant, then this is a constant, then we can take it out of the integral. So that will be divided by 18 integral of 1 minus e to the power u. So then du. Now that is easy to integrate. So then we will get negative 3 divided by 18 times, so the derivative of 1 with respect to u is u, minus, and the derivative, the integral, not derivative. So the integral is 1 with respect to u is u, and then the integral of e to the power u is e to the power u. Then we need to add a constant. But we did not finish yet, because we already know u. So u was negative 3x to the power 6. Then that means we need to change it. So here 18, we would have negative 3x to the power 6, and then minus e to the power negative 3x to the power 6, and then we can say plus a constant. I mean, of course, we can take this negative out from here and from here, and then times this negative, it will be positive. So then that means will be 3 divided by 18. Then here we would have 3x to the power 6 minus e to the power negative 3x to the power 6 plus a constant. So now this is the final answer. This is one case which is not direct, but then let us try something with trigonometric functions, maybe cosine, sine, tangent, sec, cosec, and so on, and see how do we do the substitution. So now here, let us maybe try with this example here. Let us say sine. So if we have sine to the power 4 cosine x, so sine to the power 4x, and then here we have sine to the power maybe 3x dx. So I have chosen this one, so because you see here, so I mean that is not directly clear. Here we don't have a function and it is derivative from here, right? So in this we call it I again. So I mean this is our integral. So you see, if you choose u to be sine, then we need cosine only, but we don't need cosine to the power 3x. And if you choose u to be sine, then we also, cosine, then we also need only sine. I mean, one possible solution is that this integral could be written as integral. You see, we can leave this sine to the power 4x, and then this can be rewritten as, so we could have cosine squared x, and then times cosine x and then dx, right? So I mean the main idea is we would like to get rid of this one, not to get rid of it, but to write it in terms of sine. So now we would have integral, let us do this, so sine to the power 4x, then we know that this is 1 minus sine squared x, right? So and then here we would have plus cosine x and then dx. So now you see that if we choose u to be the sine here and here, and then we already have the derivative of the sine, which is a cosine dx. So now we are safe. So now we can use integration by substitution. So of course this is something different from because the one I skipped. Okay, let us do it in the second example to tell you what I'm going to say. So but now here let us say that we have sine x, so we choose u to be sine x, but then in this case du will be cosine x dx. So now everything here will be du, and then here that we need to replace by u. So then our integral would become as follows. So here we would have u to the power 4, and then times 1 minus u squared, and then du. So this is the integral. But then we can multiply this u to the power 4 inside, then we get u to the power 4, and we multiply also by the u squared, then we get u to the power 6, and then du. So but here you see that this we can directly in this case integrate. So then that would be 1 over 5 u to the power 5 minus 1 over 7 u to the power 7, then plus a constant. But then what is u? I mean, so here we said u is equal to maybe you do it here. So we said u is equal to sine x. So here we need to change it. So we would have 1 over 5 sine to the power 5x minus 1 over 7 sine to the power 7x plus a constant. So this is the final answer. Now I go back to what I was about to say here. I mean, from the cases I showed, this is not similar. This is something different. So what is similar? So this is also example. So now we take here another example, and then maybe we can conclude this video. I mean, what I said is something like this. If we have integral, for example, of maybe sec squared, little sec squared x sine times sine, but now here we would have maybe 2 tan x and then dx. So now we can apply what I have mentioned previously. So I said that we need a function and it is derivative, something like this. So this is what I mentioned before, then times sine of a function f of x and then dx. So now this is similar. As I said, we do not really care about the coefficients always. So the coefficients in integration, they are not a problem. So, but here you see that it is obvious. This is a tan, so this is f of x, and the derivative of the tan is sec squared. So now we have all information. So now the only thing we do is to choose u to be f of x, which is a function here. So we choose u to be tan x. Then that means du will be sec squared x dx. So everything here sec and times dx, that will be du, and then here that will be u, right? So if we say this is I, my integral, so now I can be written as, so I can be written as integral. So this and this we don't need to worry about. I mean, they are all du, but then here we have sine 2u, right? So this we can easily integrate. I mean, the rule says if you have integral sine ax with respect to x, so dx, then that means, I mean, the integral would be the negative 1 over a cosine ax plus constant. Now we apply this here. So that means, so here we would have negative 1 over 2 sine 2u, then plus the constant. But now we have only one step, we change u, so we have, sorry, that is cosine, not sine. So we have negative cosine, so 2, now u we go back, so we said u is equal to tan x, so then we write it here, tan x again, so then plus the constant. So this is the final answer. So thank you very much for watching the video, and we can of course continue with integration by substitution in the coming videos. And if you are interested in more lessons, please make sure that you subscribe to the channel. Thank you again.